this video, we introduced the topic of measures of dispersion. Not like measures of central tendency, now we're interested in finding out how far apart our data is. Let's get started. So when we're talking about measures of dispersion, we want to know how far apart, that's our first fill in the blank, or spread apart our data values are from each other. The one easy measure of dispersion is called the range, and you've probably heard this one before. The basic idea is take a look at your smallest and your largest value in your data set and subtract them, large minus small, or max minus min. For example, let's suppose you have some friends whose ages are 15, 15, 19, 21, 13, and 13. So we have a total of n, our sample size in our data set here, is 6 people we're talking about. And to find the range, we would simply take the maximum value, which in this case is 21, minus the minimum value, which in this case is 13, and we would get our range of 8, or 8.00. Now notice I added 2 decimal places. When we were talking about measures of central tendency in our last video, we said we would always round 1 more decimal beyond the data itself. And when we're talking about measures of dispersion, like we are in this video, we will round to 2 decimal places beyond the original data. So 8.00 would be our range. What this means is that the ages of these friends range in a spread of 8 years. In other words, 13 is 8 years younger than someone who's 21, right? Okay, so when we have a close range, a small range, our data values are very close together. When we have a larger range, they're very spread apart. For example, I once gave a math test where the range was 98. Someone got 100 on the test, someone else got a 2%, which is why you got such a massive range. So typically on a test, for example, I like my range to be about 10 to 15 points, or even 30, 40 points. And that shows you that our tests are more closely together, our scores are more closely together. Okay, so let's take a look at our next measure of dispersion when you're ready. And that is the standard deviation. Now, what is the standard deviation? It's on average how far apart your data values are from your mean. On average, how far apart your data values are from the mean. So there's a complicated formula. You're looking at it probably right now on the slide. On the right side of the screen, you'll notice a complicated formula that's talking about how to find lowercase s, which is your sample standard deviation. So what do? We take the square root, which is what you'll see in step 6 here. You'll be taking the square root of something. The square root of what? Well, of a quotient. So you're dividing by something. So that's step 5 here, divide by 1 less than the sample size. So some sum will get divided by 1 less than the sample size. Remember, your sample size is n, so if n is 30 people, you're dividing by 29. And this is a way of accounting for the fact that samples sometimes are small and we want to make sure that we're not missing anything. So it's called a degree of freedom. We'll talk more about that in a statistics class. But in general, if you had the whole population, you could actually just divide by n, but since we have a sample, we have to be a little more careful and divide by 1 less than n. Okay, what exactly is it that we're dividing by here? Well, notice in the numerator here, we have the sigma. And remember that sigma stands for sum, okay? So we're taking the sum of something, we're adding things up. And what we'll normally do, you'll see me practice this in the 2 examples today in this video, we'll make a column of all of our x values, we'll find our differences, we'll add them up, we'll square them. And that's what we're talking about here. We're finding the sum of those squared differences. So the squared differences. We'll talk about why we have to square them in just a moment. So squaring what differences? Well, the differences we're talking about here are from step 2. We're talking about the differences between each x value and the actual x bar. What is x bar again? It was our sample mean, that's right. So we need to find our mean for our sample, and then we need to find out how far apart every data value is from that mean. When we do that, sometimes we get negatives and sometimes we get positives. For example, if a test was a 75 for an average and someone scored a 90, that means that they have a difference of 90 minus 75, or 15 points that are positive, right? 15 points above the mean. But on the other hand, someone else could score a 60 on the same test, which is also 15 points from the mean, but it's negative, right? 60 minus 75 is negative 15. So to account for those 2 test scores, we don't want them to wipe each other out. If we were to add a 15 and a negative 15, we wipe each other out. Instead, we square those differences so that we can adjust for the reality of having positive and negative differences. So that's what we're talking about there, is squaring those differences. So the very first step, though, before you can do any of this fun stuff, is we have to find the sample mean. Remember how to find x bar, the sample mean? We took the sum, there's capital sigma, the Greek letter, the sum of all of our x values divided by n, which was our sample size. So you add up all the values, divide by the total number of them. That was how we found an average, right? Our sample average, sample mean. So let's take a look at applying this complicated formula, or if you prefer, the steps that I have here. Oops, I want an eraser, not a pen. There we go. Let's take a look at how we would apply this to our first example. It says find the standard deviation for the data set that we already described, 15, 15, 19, 21, 13, and 13. So to begin, remember that first thing we wanted to do was to make a column of our data. So our data is a 15, a 15, a 19, a 21, a 13, and a 13. Okay. Now, after we've done that, we needed to find the sample mean, x bar. Okay, so let's see if you can do that. Pause the video and find the average yourself. So find that by taking 15 plus 15 plus 19 plus 21 plus 13 plus 13 and dividing by n, which in this case, n is 6, right? There's 6 friends here. So what do we have here? That's right, 96 divided by 6. And this time we're pretty lucky. We get a nice whole number in 16, and we'll round that to 16.0. Remember from our previous video, we round measures of central tendency 1 decimal beyond the data itself. So this would be our sample mean. Then we use this, that's step 1. We use this now to find the differences. We're going to find the differences between every data value and the mean itself. So this is our next column here, x minus x bar, so this column here. So how do we find those differences? Well, we take 15 minus the mean, 16. That's negative 1. Again, 15 minus 16 is negative 1. How about 19 minus 16? That's positive 3. How about 21 minus 16? That's what? Did you get 5? Good, positive 5. How about 13 minus 16? Did you get negative 3? And 13 minus 16 again, negative 3. Again, that's step 2. We found our differences. Now we need to square the differences because we don't want to wipe any out, right? A negative 1 and a positive 1, for example. So step 3 is to square those differences. And when we do square those differences, let me get a color you can see here, I'll use brown. When we square those differences, negative 1 squared is positive 1, right? How about, again, negative 1 squared, same thing, right? Positive 1. How about 3 squared? That's just 9. 5 squared? That's just 25. Negative 3 squared, that's just 9. And again, negative 3 squared is just 9. So now that I add all of these up, I get 1 plus 1 plus 9 plus 25 plus 9 plus 9. Why am I adding those up after I find all of those square differences? Because I'm trying to find this sigma here, which is our step 4, the sum of those square differences. So step 4, to find the sum. The sum is going to be 1 plus 1 plus 9 plus 25 plus 9 plus 9. And what do we get there? That's right, we get 54 for our sum. So that's our sum. Now that you have the sum, where does that go in the formula? Well, that's our numerator, isn't it? So the next step is to divide by n minus 1. So here we go. To find our sample standard deviation, we're going to have 54 divided by 1 less than n is 6, so dividing by 5. But that's not the end of it. Because we had originally squared the values, we have to undo that by taking the square root of that quotient. Now notice when you do this in your calculator, 54 divided by 5, you might get a big decimal, right? Sometimes you get really big decimals. You don't want to round until the very end. So keep that on your screen and then take the square root of that answer. When you do, you should be getting something roughly to the fact of 3.29. 3.29. Notice here I'm rounding to the second decimal place because we go 2 decimals beyond the data itself. So 3.29 is our sample standard deviation. What does this mean? This means that on average, the ages of these friends are about 3, right, away from the mean of 16, okay? So they're not going to be a lot more than that. That's kind of like the spread, if you will, 3 above, 3 below, okay? So if we have a bigger standard deviation, then the ages of these friends are more spread apart and further from the mean. But if we have a smaller standard deviation, the grouping of the data is very close to the mean itself. For example, if I was giving a test and I had an average of 75, right, 75%, and I had a standard deviation of, let's say, 10 points, then that's really nice, right? That's saying on average, most tests are going to be, within 10 above and 10 below. They're on average 10 away from the mean. But if I had, in other words, if I also had a situation of a test average of 75, but this time I had a standard deviation of, let's say, 50 points, ooh, that means that I could have someone 50 points below and 50 points above. That's quite a spread. That'd be a very nice 50 points above, but 50 points below, not as much. All right, so standard deviations, we tend to like them to be smaller. Okay, that means our data is closer together. Let's head over to the next example when you're ready. Once you have this formula written down, maybe on a note card, and you practice understanding the steps or understanding the formula itself, get ready for the next example, which I hope you can try on your own. Let's clear that screen for you. There you go. Example 1. Can you find the range and standard deviation for this data set? Here, let's say these are test scores. We have a test score of 60, 58, 62, 67, 48, 51, 72, and 70. So how do we do this? Well, that's right. To find the range, let's see what you did. For the range, remember that's just your maximum data value subtracting your minimum data value, so high minus low. Looked like it was 72 for our maximum minus our lowest value of 48. And when you did that, what did you get? Did you get 24? Nice. Now technically, again, you would say 24.00 to be precise. We do 2 decimals beyond the original data. So 24.00, or about roughly 24 points, is our spread from our lowest to our highest, or our highest to our lowest. Now for finding the standard deviation, on the other hand, remember that first step was to list your data values, okay? So for example, your first one is a 60, your first X, then 58 as the column here, 62, 67, 48, 51, 72, I'll try to make another column here, I meant row, sorry, and 70. Okay, once we've done that, what was the first official part of the formula? That's right, we needed to find those differences. So the difference between X and X bar, but to do that, we needed which value? That's right, we needed X bar. So to find X bar in this formula here, to find X bar, what did you do? Right, you added them all up and divided by the total number of them. Hey, what is your total number of values here? 1, 2, 3, 4, 5, 6, 7, 8 is correct. So n is 8 in this example of this data set. So we would be dividing by 8 for our mean. Now, if it was standard deviation, we divide by n minus 1, divide by 7. But for the mean, it's still just dividing by the total number of items. So when you add all of those values up, what did you get? Did you get 488? Hopefully that's what I had. And 488 divided by 8 gave me 61, or 61.0. Remember, for measures of central tendency like the mean, we can just round to one more decimal than the data itself. So that's why it's 61.0. Okay, so next up, we subtracted each of our data values, not subtract from, but rather subtract the mean from each of the data values. In other words, X minus X bar for consistency. When I did that, what did you get? When you did that, what did you get? Well, you did 60 minus 61, which hopefully gave you negative 1. Or you did 58 minus 61, which would have given you negative 3. Or 62 minus 61, that's positive 1. Or 67 minus 61, well, that's positive 6. Or you did 48 minus 61, and you got negative 13. Or you did 51 minus 61, and you got negative 10. Or 72 minus 61. In that case, you got 11. And then 70 minus 61, you got positive 9. Now, after you did that, you got positives and negatives. And what did we do to account for that? Do you remember? That's right, we squared each of those values. So we square each of those values, and the purpose of that is so that we don't wipe out a negative with a positive. So there's a reason behind everything in this formula. Okay, so when I did that, negative 1 squared is positive 1, negative 3 squared was positive 9, 1 squared is just 1, 6 squared was just 36, negative 13 times negative 13 was 169, it's positive now. Negative 10 times negative 10 is positive 100, 11 squared is 121, and 9 squared was 81. Okay, what did you do next? Do you remember on your formula? That's right, next up was find the sum. So find the sum of those square differences. So the sum in this case would be 1 plus 9 plus 1 plus 36 plus 169 plus 100 plus 121 plus 81. And when you do that, did you get 518? I hope so. Now, once you have the sum here, what did we do next? Good, we said to find the sample standard deviation, we take that sum, which was 518, we divide it by 1 less than n. So 1 fewer than 8 would be 7. But the final thing we have to do, if you were to plug that in right now, you'd notice your answer is really big and it doesn't make a lot of sense with your data. So what we had to do is we had to take the square root of that answer. So do 518 divided by 7, whatever you get in your calculator, then take the square root. And what do you get? Did you get that S is approximately 8.60 when you rounded the 2 required decimal places? Hopefully, yes. And so what that is saying is that on average, your test scores will be as far apart as 8.60 from the mean of 61. So they're not going to be more than that typically, more than that distance away. Okay, so they're pretty close together. This would be a very nice situation if I was giving a test. The only thing that's not so nice is that they're a little bit on the lower end. We would prefer that they'd be close together and maybe in the A's and B range instead of the D's and F range. Okay, well, we practiced a lot in this video of how to understand standard deviation and the other measure of dispersion, range. One's definitely easier than the other. If you have any questions, please reach out to me. Otherwise, happy practicing because math is not a spectator sport. I'll see you next time.